This video covers sections probability E4 to E7. To begin, let's go back to independent events. Now, when one event affects another, they are said to be dependent, and conditional probability must be considered. Now, the situation arises when items are not replaced before we select further items. So, for example, if I pick a card from a deck of cards, if I don't put that back, whatever I chose the first time is going to affect whatever I choose second. Also, there's now only 51 cards to choose from. Now, the calculation of probability of the second event occurring after the first has already happened, you'll need to consider those change values for the remaining number of outcomes, still using the same formula. So let's look at some examples. 2 balls are drawn without replacement from a bag containing 2 red, 3 green and 5 blue balls. Find the probability of drawing a red ball second if a blue ball is drawn first. Well, let's see what we've got. There are still 2 red balls, there are still 3 green balls, but there are now only 4 blue balls because I already drew a blue. So the probability of getting red is going to be 2 out of, how many balls do we have in total? 4, 7, 9. So 2 out of 9. Here a red ball is drawn first. Well, now I only have 1 red ball left. I still have 3 green and I have 5 blue. So the probability of red is going to be 1 out of 9. Pause the video, have a go yourself. Okay? 3 cards are drawn without replacement for a pack. Find the probability that the third card drawn is an ace if the first 2 cards are aces. For aces left, if the first 2 are aces, is only 2. Okay? And total cards, well, I've already drawn 2, so I'm only going to have 50 left. So the probability of an ace is going to be 2 out of 50 or 1 out of 25. The first 2 cards are kings. Well, now I still have 4 aces left, but I still only have 50 cards to choose from. So the probability of an ace is going to be 4 out of 50, which reduces to 2 out of 25. Last, the first card is an ace and the second is a king. Well, that means I now have 3 aces left out of a total of 50 cards. So probability of getting another ace is going to be 3 out of 50. Now let's look at conditional probability. Now the probability that an event B occurs given an event A has already occurred is called conditional probability, and you can see that here. So the probability of B given A equals the probability of A and B over the probability of A. So let's look at an example here. A die is rolled. What is the probability that a value of 2 is obtained if an even number is rolled? So we already know we've rolled an even. So what's now the chance of having a 2? Now you should realise, well, if I already know it's even, it can be one of 3 things. So 1 in 3. But let's show why. So the probability of 2 given even is going to be the probability of 2 and even over the probability of even. Well, the probability it's 2 and even is 1 in 6, and the probability of an even is a half. Okay, so that means I've got 1 over 6 divided by a half, which is the same as saying 1 over 6 times 2 over 1. Cancels, 2 into that is 3, 2 into that's 1, so I have 1 over 3. Okay. Here a card is drawn from a pack. What is the probability that a card is an ace given that a heart is drawn? So we've got the probability of ace given that I have a heart. So the probability of ace of hearts, so that means the probability of ace and the probability of heart over the probability of a heart. Probability of ace of hearts is going to be, well, there's only 1 in a whole pack, so 1 over 52. Probability of heart, well, there's a quarter of the pack, or 13 over 52. So I have 1 over 52 divided by 1 over 4, which is 1 over 52 times 4 over 1. We can cancel on the diagonal. 4 into that's 13, 4 into that's 1. So my answer is 1 in 13. Now let's look at the multiplication law for dependent events. The multiplication law of probability for dependent events incorporates conditional probability. And you can see that here. All it is the formula rearranged. Okay, this is what we started with over here. Probability of B given A equals the probability of A and B over the probability of A. So if I want to isolate this here, okay, I'm trying to isolate this here, all I'm doing is multiplying both sides by probability of A. So you can say the probability of A and B is the probability of B given A times the probability of A, or probability of A times probability of B given A. Now, if two events A and B are independent, then the probability of B given A has to be the same as the probability of B, because they don't affect each other. And we also know that the probability of A and B is the probability of A times the probability of B, because of our multiplication law. So let's look at some examples. 2 balls are drawn without replacement from a bag containing 2 red, 3 green and 5 blue balls. What's the probability of 2 red balls? Well, what we're looking at is the probability of red, then red. So that's going to be the probability that the first is red times by the probability that the second is red. Well, the probability of the first being red is 2 out of, we've got 5, 8, 9, 10 balls, but we've already selected a red. So now we've only got 1 red left out of 9. So that gives us 2 out of 90. Okay, next a green ball and then a blue ball. So here we've got probability of green, then blue. That's going to be the probability of green times by the probability of blue. So the probability of getting a green is 3 out of 10 times by the probability of blue. Well, there's still 5 blue balls, but we only have 9 left. So that's going to be, we can simplify on the diagonal. So we're going to have 5 over, I can simplify on the other diagonal, can't I? Looking at this diagonal, 5 into 5 is 1, 5 into 10 is 2. So I have 1 times 1 is 1, 2 times 3 is 6, so 1 over 6. Next, 3 cards are drawn without replacement from a pack. Find the probability that the 3 cards are aces. So from here, I'm going to abbreviate ace, then ace, then ace. So that's going to be the probability that the first is an ace times the probability that the second is an ace times the probability that the third is an ace. They're all ands, and that's why it's multiply. So the first is an ace. We've got 4 out of 52 aces. We've already selected 1 ace, so now we've only got 3 out of 51 left. We've already selected 2 aces, so now there's only 2 out of 50 left. Okay, simplifying on some diagonals. 2 into 4 is 2, 2 into 50 is 25, 2 into 2 is 1, 2 into 52 is 26. I can also cancel going down this way. 2 into 2 is 1, 2 into 16 is 13 times, and that might be all I can do. So now I have 1 times 3 times 1 is 3, 13 times 51 times 25, which is yuck, which is 16575. See if I can reduce that any further. I can divide top and bottom by 3. Remember, you don't have to do all this by hand. Use your calculator. You get 1 over 5,525. So use your calculator to help you with the fractions. I've done it by hand, so you don't need to do that. Next, the first 2 cards are aces and the third is a king. So we want the probability of an ace, then an ace, then a king. So it's going to be the probability that the first is an ace times the probability that the second is an ace times the probability that the third is a king. We're an ace first. I got 4 out of 52 cards. Next is an ace. Well, I've already chosen one, so it's 3 out of 51. Third is a king. Well, there's 4 kings out of 50 cards left. See if I can simplify. So 2 into 4 is 2. 2 into 50 is 25. Probably would have just been easier simplifying here, but anyway. 4 into 4 is 1. 4 into 52 is 13. Can I do any more? Doesn't look like it, so now I'll multiply. 2 times 3 times 1 is 6. Now I go to the calculator. 13 times 51 times 25 is 325, and then see whether I can reduce that. Okay, this number should actually be 13 times 51 times 25 is 16,575. Sorry about that. Then try and reduce that. You should be able to divide top and bottom by 3 maybe. So let's divide the bottom by 3. So divide the top by 3, the bottom by 3, and you end up with 2 over 5525. Okay, remember you can do this on your calculator. 4 fraction button 52 times 3 fraction button 51 times 4 fraction button 50. Use your calculator to help you. Don't freak because of the fractions. Okay, next the first card is an ace, the second is a king, and the third is a queen. So we've got probability ace, king, queen equals the probability if first is an ace times probability that the second is a king times the probability that the third is a queen. So from here I have 4 out of 52. King I still have 4 but out of 51. Queen I still have 4 but out of 50. Okay. Just multiply across, you don't have to reduce. So what I'm saying by there, you can just go 4 fraction button 52 times 4 fraction button 51 times 4 fraction button 50, and you'll get an answer of 8 over 16575. So you can use your calculator to help you out. Last thing for this video, non-mutually exclusive events. Now when events are not mutually exclusive, the addition law of probability can be used in the following form. So you can see here the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Now I actually find the easiest way to show this is with sets. Now they're not mutually exclusive, so that means there's an overlap here. So you can see we're looking at the probability of A, so that's all of this bit. Then we go the probability of B, which is all here, but you can see what's happened is I've added this bit twice. So I need to take away the probability of both A and B occurring. So let's look at an example. A card is drawn from a pack. What is the probability that a card drawn is an ace or a heart? So the probability of ace or a heart is going to be the probability of an ace plus the probability of a heart minus the probability of the ace of hearts, because that's the overlap. This ace could have been a heart, this heart could have been an ace. So we have 4 over 52 plus 13 over 52 minus 1 over 52. That gives us 16 over 52. So 4 plus 13 is 17. 17 minus 1 is 16 over 52, which is 4 over 13. Okay, there's a lot in this video. You might want to listen to it again. The exercises are probability E4 and E5 in the textbook.